Bright Tuty. Every student matters.
Second, and quite importantly, the second type of graphs we will be taking will be the velocity or speed. One or the same thing, velocity time graphs. Now, when I have said velocity or speed, one or the same thing, only in graphs. Whenever we are talking about a linear or a straight line motion, otherwise earlier in the chapter we have seen that velocity and speed are different. Speed is a scalar quantity, velocity is a vector quantity. Velocity has direction as well as magnitude, speed has only magnitude, right. So, just for the sake of saying in graph in linear motion, velocity or speed, if it is given to us in the question, we are assuming that they are the same thing, velocity time graph, or we call them VT graphs, because velocity or speed are represented by small v. Now, when we are plotting these type of graphs on the y axis, we will be taking the velocity of the object or speed in the unit given to us, whether it is meter per second or kilometer per hour. On the x axis, we will take the time, which is either in minutes or in seconds or in hours, depending upon the information given to us, right. Now, as we have seen in the distance time graph, here also if we relate, for example, we are taking an example, we are taking the hypothetical values of time, we are taking the hypothetical values of velocity, that a body is moving with a velocity of 10 meter per second, 20, 30, 40, 50, 60, or after 5 seconds, 10 seconds, 15, 20, 25, 30. Now, whenever we plot a graph, we will say that what exactly is given in the question, as per that after how much time, what exactly was the velocity of this particular object. Fine. Depending upon the graph made, we will have various options. Let us see what are the options we will be having. I am making this VT graph. Now, if on a VT graph we get a straight line, after putting the data and after making the graph and joining the points, if we get a straight line, then this VT graph straight line shows that the body is undergoing uniform acceleration. Now, this is important, students. Why important? Because if the same straight line we have got in the distance time graph rather than velocity time graph, it would have represented uniform speed or uniform motion. But here in the VT graph, it represents uniform velocity time graph is uniform acceleration. It represents uniform acceleration, correct. Why acceleration? Because the straight line shows that with equal intervals of time, the velocity of this particular object is also increasing consistently, uniformly, and in the same ratio. That is why this VT graph, it shows the straight line of the VT graph shows uniform acceleration. Fine. But if we draw the same VT graph and we get a curve in the upward direction, this particular graph shows that with the passage of time, the velocity is increasing because it is going upward, but because it is a curve, it means it is non-uniform acceleration. The velocity is increasing, the body is undergoing acceleration, but it is non-uniform. Got it? Fine. Quite importantly, if the same VT graph we make and now we get a straight line coming downwards. Now, this particular line coming downwards indicates retardation. How? Let us try to relate. Initially, we saw that this was a straight line going up. The velocity, if we talk about straight line going up, the velocity was increasing from 10, then to 20, then to 30, then to 40, and then to 50. So, that means the velocity is increasing with time, which shows that the body is accelerating, right. But if the same thing we try to relate in the graph, and we see that a line is coming downward. Now this shows that initially the body was moving at a higher velocity, and with the passage of time the velocity is decreasing. So this line coming downwards shows retardation, and again if it is a straight line it will be a uniform retardation. Got it? That the body is retarding uniformly. Similarly, if we get the VT graph and now we get a slope or a curve in the downward direction, this once again signifies retardation, but now because it is a curve, then we interpret that it is a non-uniform retardation. Got it? So in VT graph, I repeat, I am highlighting, I am emphasizing, I am just putting some more stress on this particular thing, that whenever you are being shown a graph, the very first thing you need to relate is which graph it is. What exactly is the information conveyed in the x-axis and y-axis? That is it a distance time graph or a velocity time or speed time graph? If it is a distance time graph, then we have seen different interpretations. That is, either it is straight line upward, uniform motion, uniform speed, or a curve upward, non-uniform motion, non-uniform speed, or a parallel line to x-axis showing stationary object. But when we talk about velocity time graphs, then in that case we have different options that we have discussed. We will repeat that a straight line upward is uniform acceleration. A straight line, not straight line, a curve upward, that is non-uniform acceleration. So if the line is going upward, right, either it is in the form of a straight line or a curve, it shows acceleration. If it is a straight line, uniform, curve, non-uniform. Similarly, if the lines are going downward, in that case, in these two cases, we say that it is retardation. It is negative acceleration because the velocity is decreasing. Now, if it is a straight line, it is uniform retardation, and if it is a curve, it is a non-uniform retardation. Got it? Very importantly, again one more thing, VT graph. What if we take a parallel line parallel to x-axis? Now let us take the values, assuming it 10, 20, 30 and 35, right. So time is 5, 10, 15, 20, 25. After, let it be in seconds, let it be in meter per second. After 5 seconds, I see the velocity is 35 meter per second. After 10 seconds, when I again observe the motion of this object, it is again moving with 35 meter per second. After 15, again 35 meter per second. After 20, again 35 meter per second. So this particular straight line shows that the body is moving with constant velocity or constant speed, and whenever the body is moving throughout with the same speed, that simply means that the acceleration is 0, whether it is positive or negative, both, because with the passage of time neither the speed of this car is decreasing nor it is increasing. So it is moving at a constant speed of 35 meter per second. Got it? Fine. So these are the 5 things that we may be asked in the question. We will be given a particular graph, and in that graph we will be asked what type of motion is shown by the body in either of these graphs. So in the first graph, the motion shown by the body is uniform acceleration. In second graph, it is non-uniform acceleration. In third graph, it is uniform retardation. In fourth graph, it is non-uniform retardation, and in fifth graph, it is zero acceleration or constant speed. Got it? This is very, very important, because while we will be taking up the next topic, in the next topics, and while solving the numericals based on graphs, these things will be coming into action. So you need to remember what is the information conveyed by distance time graph and speed time or velocity time graph. Please try to practice them, and next we will just see about how these things will be utilized while doing the numericals. Thank you for watching. Thanks.